Hi, welcome. I wasn't expecting that much people. So I'm Bruno. I'm a software developer. I work at Xero. Xero is a cloud-based company. We have a bunch of cloud-based software for accounting, and we have 700,000 customers all around the world. So we want our websites to be performant for our customers and cost-effective for our infrastructure. And that's why we have a dedicated team dedicated to performance and scalability, which is the team I work with. All our websites are based on ASP.NET, so I'm very interested in .NET Core and ASP.NET Core. So the talk is titled .NET Core for .NET developers. Are you guys, all of you are .NET developers? How many .NET developers do we have? Wow, okay. You guys are .NET developers. Cool. That's awesome. Have you ever played with .NET Core? Good, not many of you, so I can tell you whether I want. Just joking. So if there is only one thing you should take away from this talk, so if you want to build .NET applications and services which are portable and efficient, you should use .NET Core. So I'll start by talking about the key features of .NET Core, key features in my humble opinion. Then I'll give you a little demo about how to create a simple .NET Core app in Visual Studio Code, just to show you the differences with what we have at the moment in .NET. Then I talk about the broad goals this new piece of technology is going to tackle, and another demo about ASP.NET Core and how to use Docker. The demo will be on my local machine, but you could probably do the same thing with Windows Docker services, Windows containers, sorry, and Azure containers as well, because the client is Docker. It's the same client, just the libraries are different. So let's start with the key features. .NET Core is the first implementation of .NET, which has all these features at once. It is open source, but supported. It is cross-platform. It has a new a new way of deploying that we didn't have with .NET. And it gives you a flexible developer experience that I'm going to talk to you about. So it's fully open source, like I said, and the code is in GitHub. And if you want, you can contribute to it. So it's not like the .NET framework, which is read-only, open source. You can actually take an issue and fix it if you want. It's part of the .NET Foundation community. If you navigate their homepage in GitHub, you will see 45 repositories. There are many. Most of them are dedicated to Roslyn and .NET Core. If you just want to use .NET Core, you don't need to clone Git repositories. You don't need to build it on your machine. You can just use the distributed SDK or just the runtime if you don't need to develop with it, but I suppose you would, since you're all .NET developers. So that's the website, the web page you should navigate if you want to see all those 45 repositories. I've listed the main 3 plus 1. Why did I list these ones? Because they let me explain you the main parts of .NET Core. So Core CLR contains the runtime. You can read the code if you want, and the main types. So basic types, the CLR, the GC, the JIT compiler, and such. CoreFX contains basically the libraries you would expect to have available when you work with the .NET framework. Not all of them, but they are currently extending it very much compared to what it was a few months ago. I'll talk you about that later in more detail. Basically, it's collections, file system, console, XML, asynchronous support like task library, and so on. The CLI command line tools, because in .NET Core we have this command line tool called .NET. It's an exe file, or an executable if you run on Linux, not an exe file. But anyway, executable. And you can use the same, the same tool to create new apps, build them, compile them, run them, package them, and also to run tests. So these are the three main parts. The last one, /core, if you've never had anything to do with .NET Core, that's probably where you should start, because it's basically a collection of documentation, links, things you should start from. It has links to all these three repositories, plus other ones, plus a link to ASP.NET Core repository. So to recap, .NET Core is fully open source, and the code can be found on GitHub. About the developer experience, it's flexible in terms of tools and platforms, because you can develop on Mac, Linux, or Windows using one or a combination of those tools you can see up there. So Visual Studio, Yeoman, if you know it, the CLI, which is .NET, command line thing, and one of those 6 text editors. If you know them, you will recognize the logos. So this table gives us a better understanding. So if you're on Windows, you can use only Visual Studio 2015, update 3 with the tooling. Otherwise, on Mac, Windows, or Linux, you can use one of those 6 editors, Brackets, Atom, Vim, Emacs, I forgot that one, and Visual Studio Code. So why those 6? Because they're all supported by OmniSharp. Yeoman has some generators that can help you scaffolding the apps and Dockerize them. That's what I'm going to show you later. And obviously, the CLI runs on all the 3 supported environments. So what's Visual Studio Code? I mentioned it. So it's a code editor, lightweight, open source, free, multi-platform, and supported. I'm going to demo it in the first and the second demo. What's OmniSharp? I mentioned it. So OmniSharp is a collection of .NET development tools, and that enables one of those 6 editors you might want to use to highlight C# code, debug .NET code, and such. I tried only the add-on for Visual Studio Code. Yeoman, if you don't know it, it's basically a code generation tool. There are a bunch of generators that people use to generate any and scaffold any kind of apps nowadays. So to recap, you can develop on Mac, Linux, and Windows using a variety of development tools. Another crucial feature is .NET Core is cross-platform because it is being designed to be cross-platform, and it runs on Windows, Linux, and Mac. So if you navigate to that core repository, the one with the documentation, and you look at the roadmap.md file, you'll see this detailed table that shows the supported operating systems for the version 1.0. So basically, it's telling us that the x64 architecture is supported on all those Linux distributions, Mac and Windows, where x86 is Windows only. I think ARM32 and 64 are under development. Not sure about what stage they are at the moment. Last but not least, flexible deployment. So you have two kind of deployments, two kind of ways for deploying code in .NET Core. FDD, which means framework-dependent deployment, and SCD, which means self-contained deployment. So FDD is what we already are familiar with. You ship your DLLs, your application, deploy it on a machine that has .NET Framework installed, and that machine has to have the right version of .NET installed. SCD instead, self-contained deployment, means you're shipping the framework with your app. So with websites, you could have, if you wanted to, different websites running with different versions of .NET Core on the same server, on the same development machine usually. Because on servers, you would probably containerize them and stuff like that. So it makes it easier. For client apps, you don't have to worry about your clients and customers installing the right version of .NET because you will be shipping the framework. So I'm going to demo this now. What I'm going to do is I'm going to create a simple .NET Core application to show you the structure of a .NET Core project, which is different from .NET, from what we are used to at the moment, and some of the features of Visual Studio Code. And I won't use Yeoman because I want to use just the bare minimum things that you need. So prerequisites are just the runtime and Visual Studio Code. And then I'm going to write the code on a Ubuntu machine that has .NET Core installed, a virtual machine. Then I'm going to build it in Windows. And I'll take the thing that I built in Windows and I'll run it on an Ubuntu machine that does not have .NET Core installed to demo the self-contained deployment feature. So I should switch. It's switching. You probably recognize the planet. So let's open up the command prompt. And I'm gonna, so I said I should do that in a virtual machine, sorry. So let's fire up the virtual machine. And I'm going to do this in a shared folder that I prepared. So I'm going to create folder, ignite, and open terminal. So we could do the same thing in the command prompt in Windows. So we're going to use the .NET command, which is the CLI, to create a new little console application with .NET new. And what do we get? Create a new C# project. We get two files, project.cs, project.json. No solution file, no csproj file, nothing like that. So let's open up Visual Studio Code with this command. I could use the GUI, but it's much cooler to use the command line. And here we go, Visual Studio. So this is a version of, this is Visual Studio Code with very big characters. So yeah, so that you can read it. It usually looks like less cumbersome, you know. So let's talk about this a little bit. So it has 5 main sections. A file explorer you can use to open files, create new files, blah, blah, blah. Search, that is, you can imagine a search engine for the files. It found the hello in our hello world. So yeah, I don't need to explain this thing, right? Git, I don't have Git on this virtual machine, but if you wanted to, you could use Visual Studio Code to set up and manage your Git local repository. It has a debug section, and then the extensions. I have only one installed, the C# extension provided by OmniSharp. So, do you want me to run the demo first or talk about the project.json? I'll run the demo first. So this thing just prints out hello world. Let's make it do something slightly more colorful. And I mean just a little more colorful. So this will print hello world in 3 different colors, green, white, and red. Why green, white, and red? It's the Italian flag. Yeah. So another cool feature, if you hit Control backtick in Visual Studio Code, it opens up the terminal. So in Linux, it opens up a bash terminal, in Windows, command terminal, and so on. So first of all, we need to do .NET restore. And this creates another file. Look at here. It's reading the project.json, and it creates a project called lot.json, which I'll talk to you about later because I want to run the demo first. And then we can run it by typing just .NET run with no other parameters. So in this case, it will figure out what it has to run by itself by probably looking at the project.json. Otherwise, we would have to tell it what we want to run. And it does what it's supposed to do. Hello world, hello world, hello world. So let's see what happens if we put a breakpoint here and we try to run it from Visual Studio Code by hitting F5 very intuitively. And it says select environment. So since I haven't used Yeoman, I have to set up Visual Studio Code to run a .NET Core app. And what I need to do, so this launch.json that gets created when I hit the, when I select the .NET Core after I pressed F5 is a collection of 3 configurations that I then can run from the debug section. So first of all, I will delete the ones that I don't need, which are web and attach and the comma. And the only thing I have to do here to set it up is to tell it the right path that I can figure out from Visual Studio Code but after I build it. So it's, I'm going to explain this, don't worry. NetCore, oops. NetCore 1.0, Ignite, DLL, save. F5 again, it says we don't have a task runner. We have to select the one for .NET Core. This task runner does one thing. It builds our app. There's a task named build. And in the launch.json, there's a pre-launch task called build, which matches. So we have our breakpoint in the program.cs, F5. There's a little thing spinning down here if you don't see it. And we are debugging. So unfortunately, this debug console here does not support colors. So everything will be sad and gray. Hello world. But this lets me demo that I can change this while I'm debugging like I would do in Visual Studio. Set value hello ignite, ignite, F10, F10, and down here we see hello ignite, and then I set it back to hello world, world, F10, F10, so hello world, hello ignite, sorry, expand it, hello world, hello ignite, hello world again. Okay, so this is how you can debug and functionally debug like you would be in Visual Studio with Visual Studio Code. Now, you will be probably curious about this app not having a CSproj file, not having a solution file. So about the CSproj files. So in the CSproj file, we basically have 2 things. We have paths to codes, to code files, like the program.cs, and paths to DLLs. So now, with .NET Core, every file that is contained in this folder, every CS file, will be used. So you don't need to have any other file that tells your project where are the components that it has to compile. And about the DLLs, we don't reference DLLs directly with .NET Core. We reference NuGet packages. Yeah. So this thing here in this dependency region, Microsoft.NET Core.app, is a NuGet package, ultimately. And in the .NET Core terminology, it's called a meta package. So this is important. .NET Core is modular in the sense that every DLL, like System I/O, like System Runtime, is shipped in a separate package. So if you want, you can just pay for what you use and tailor your dependencies to get exactly what you need. But since it will be unpractical when you're creating an app to reference all the separate packages, and you should also match the right versions to ensure that they are compatible with each other, they have bundled them up in these meta packages like Microsoft.NET Core.app. Then, when you run .NET Restore, NuGet creates a project.log.json file, which is very long. It has two main sections, targets and libraries. So targets is one for every combination of framework and runtime. We haven't specified the runtime yet. And libraries is basically a detailed explanation for all those packages you have. It maps the packages to DLLs. And that's how DLLs are then referenced, right? So for instance, if you search for system.io.compression, you will find paths to the DLLs, system.io, and that's how the DLLs are referenced in .NET Core. So this app is FDD at the moment, Framework Dependent Deployment. If I use .NET Publish, which is the command you need to use to publish your app, it creates a folder that basically contains what you would ship as your application. And if we navigate it, let me minimize Visual Studio and bin debug netcore app publish. You can see there's just our DLL. So the application is a DLL in .NET Core, unless you ship it as an SCD, because you need the .NET CLI to run the console app, which is a DLL. So how can we ship it as an SCD? I'm going to want to do this in Windows now. So I'll open up Visual Studio Code, and I'll open the same folder that I was sharing with the virtual machine. So we have to do two things. First of all, we need to tell .NET Core that Microsoft.NET Core app is not available in the platform, has to be shipped with our app. And then we need to specify another section here called runtimes. So we need to tell .NET Core which runtimes we are targeting. And the runtime we're going to target is Ubuntu 16.04, sorry. Okay. So this is the modifications we need to do to the project.json. So tell it not to expect to find the packages on the machine, and select at least one runtime. And then, now from Windows, we can do .NET publish-r. We need to specify the runtime name, which is Ubuntu.16.04-x64. Oh yeah, we need to do .NET Restore first, because since we added a runtime, we need to get the packages for that runtime. Oh, it was quick. And .NET Publish. Now, this creates another publish folder, bin, debug, netcore app, Ubuntu, publish. And this one has some more stuff. So the whole framework. And our app, Ignite, is an executable here. Now I'm going to just copy this a little up on the hierarchy. It's easier to manage. And then on another Ubuntu machine that I have here, with a different theme, so we can distinguish between them. Thank you. I'm going to open the same shared folder, publish, and I'm going to open the terminal, and just to prove that I don't have .NET installed here. It says command not found. So I need to tell Linux that Ignite is executable, and probably using sudo ignite. Right. So we coded it in Linux just because we could with Visual Studio Code. Then we built it on a Windows machine, and we're running it on a Ubuntu machine that does not have .NET Core installed because we've shipped it as a self-contained deployment. How confusing is it? A lot, sorry. I tried to make it as clear as I could. So that's it for the first demo. Now let's go back to the boring speaking. Broad goals that this piece of technology is going to take on. So I'm going to talk about performance and scalability and benchmarks, stuff that I really like, Docker and .NET Core, but first of all, compatibility. You might have heard of .NET Standard. Yes? No? Some people? If you know the portable class libraries, it's basically the next generation of portable class libraries. And this is how .NET Core can be compatible with the .NET Framework, Xamarin, and Mono through the .NET Standard library. So if you write your custom .NET library .dll using a certain version of the .NET Standard library, your custom .NET library DLL will then be compatible with .NET Framework, .NET Core, Mono, and Xamarin, provided that you've used a certain version of the .NET Standard library which is compatible with them. So this table can give you an idea. So while I leave this table back here, I'll tell you about .NET Standard. So the .NET Standard is a collection of APIs. Every version is a collection of a certain version of certain APIs. And you can think about it as a framework you can target, even if it's not a real framework. It's a framework defined by a set of APIs. So every version of the framework is defined by a certain version of a set of API. So in this table, you can see the compatibility between the different versions of .NET Standard. Oh, it's on GitHub, by the way, somewhere in one of those. It's referenced at the end of the presentation. I have a slide with all the references. So for instance, if your library targets .NET Standard 1.3, you can use it in .NET Core, .NET Framework 4.6, and subsequent UWP, Mono, and Xamarin, but not Windows Phone and such. Good news, they are all retrocompatible. So 1.6 is retrocompatible with 1.5, and so on. Have you heard of .NET Standard 2.0? If you've been following the .NET Core adventure, you might have heard of it. There's been lots of talking. Currently, it's still in work in progress. The novelty a few days ago is that it will still be compatible with .NET Standard 1.6. They were about to cut the compatibility. So it's separate from .NET Core. This is the key thing. .NET Standard is not .NET Core. They're two separate things. And the reference libraries are on a separate GitHub repository. If you're interested in .NET Standard, I have some demos. I decided not to include them in the presentation because of time constraints. So I'll be here till Friday. Feel free to approach me if you're interested. So yeah, to recap, Microsoft .NET Core is compatible with .NET Framework, Xamarin, and Mono through the .NET Standard Library. Performance and scalability. We probably all know how much performance and scalability are important, especially on web apps, in terms of efficient use of CPU, not blocking I/O, like asynchronous I/O, and usage of memory. So, excuse me. Yeah. Before talking about performance and scalability, I should talk about ASP.NET Core and NuGet. So to achieve optimal usage of memory, .NET Core is modular, and ASP.NET Core is also modular. They tried to break it in small pieces, little chunks, so that you can load in memory only what you really need to use. So ASP.NET Core, you might have heard of ASP.NET 5. It's the new name of ASP.NET 5, and you can consider ASP.NET 5 dead. It's a redesign of ASP.NET. It shares many of the features of .NET Core, so it's modular, broken into many small pieces, portable, and basically doesn't depend anymore on system web DLL. They have broken that DLL in small pieces, so you don't need the big mammoth if you just need little parts of it. It can be self-hosted. It offers built-in dependency injection, which is always handy. And it's open source. So like .NET Core, you can find it on GitHub/ASP.NET. There are many repositories you could look into. I've picked the two ones that let me explain the important things about .NET Core. So /MVC contains basically ASP.NET Core. So the MVC part of ASP.NET Core, web APIs, web pages with Razor, no web forms. There's no web forms in ASP.NET Core. The other one, Kestrel HTTP Server, is the code for a lightweight web server called Kestra, which is one of the ways that they have decided to optimize performance with ASP.NET Core. So Kestrel is a lightweight web server, and lightweight means it doesn't have many of the things that you would expect to have for a web server, like SSL termination, URL rewrites, gzip compression, etc. So it's based on a library called libuv that does asynchronous I/O. So that's why it's considered the recommended way to host ASP.NET Core applications. So use it, but put a reverse proxy in front of it, like Nginx or IIS, so that those guys can deal with all the things that Kestrel can't do. About the ASP.NET Core performances, one of those repositories you can find on the ASP.NET GitHub website is called Benchmarks, and it contains benchmarks, as you can probably imagine, and all the instructions to set them up. So if you want to run them again and prove that the results that they give you are the same that you get, you can do that. And those benchmarks are taken from techempower.com. Techempower.com is a company. They run benchmarks every like a few months, and I think it was November 2015. They ran it against ASP.NET MVC Mono, and the results weren't good. So the MVC team decided to tackle that problem, and they came out with .NET Core, ASP.NET Core, and a few months later they hit their target, which was 1 million requests per second on a plain text request. So those results are on the website. I graphed them for you. So this is the request per seconds. Did I say per seconds? Per seconds, plain text, comparison between ASP.NET Core, IIS static files, Node.js, and the ASP.NET 4.6 running in the .NET framework. And if we add HTTP pipeline, oh, sorry, take the picture. And if we add HTTP pipelining, the results goes dramatically up in favor of ASP.NET Core with Kestrel. On Windows it performs slightly better than Linux. So yeah, they have optimized the memory by loading just the pieces that you need, so pay for what you use, and asynchronous I/O with Kestrel to be non-blocking. Last but not least, Docker. Do you know Docker? Have you been to one of those Azure Containers talk or Windows? Yep, I see one hand, 2 hands. Yep. So Docker is a first-class citizen in the .NET Core world. Microsoft invested some effort on making it easy to develop and host in production. You should probably know. So it's basically a lightweight virtualizer if you don't know it. It runs on Linux, but the Windows containers use the same Docker client to run their containers. And basically, it's like a virtualizer, but without the overhead of the guest operating system, to put it simple. And to help you develop, build, and run in production .NET Core application, Microsoft offers 3 flavor on that website. 3 flavor of Docker images you can use. Each one is designed to tackle different priorities we have at the different stages of our development process. So while we develop, we want to be able to quickly iterate changes and remote debug into the container that is running our app. And I'm going to demo that in a few minutes. During the build process, usually to set up a new build process, in your CI, for instance, pipeline, you need to install the components on the build agents, maintain them, install the new versions when the new version comes out. So if you instead use a Docker container to run the build, your build agent just has to take your code, put that into the container, and the container will have all the build tools to build an optimized version of your app that's ready for production. And instead, the production image is designed to be small, performant, and it has pre-jitted assemblies on it, so that it's okay, because containers are supposed to be immutable, so we can pre-compile. And Docker helps us Yeoman helps us to Dockerize our application. So, second demo time, and we are perfectly on time. Let me switch. So what I'm going to do now, I'm going to create a simple ASP.NET Core Web API using the Yeoman scaffolding tool. I'll run it on my machine locally, hosted on a console app using Kestrel, which is the default. Just had to hit F5. And then I'll run it in a Docker container on my machine. And everything comes basically out of the box. So here we go. I don't need VMs anymore. I can close the folder here and open command prompt, Ctrl+C. So here we go. Create the folder, another ignite here. It exists, oh sorry. Ignite. And now, prerequisites, same prerequisites as before, plus you need npm to install Yeoman. So then you would have to install Yeoman, npm install -g Yeoman. I don't need to do that, so I won't hit enter. Then you need two generators for this demo. One for ASP.NET, which is called generator ASP.NET, for ASP.NET Core, sorry, and one for Docker, which is called generator-docker. Then, using Yeoman, you can scaffold your ASP.NET Web API with Yo ASP.NET, which calls the generator ASP.NET you've just installed. And in a while, the Yeoman will come up asking us what we want to build. Here we go. So we could decide to create a console app, web application, but we want to build a web API, and let's call it API. And it's done. So now we have an API app scaffolded that will run on our local machine. Sorry, I know that you can't read the prompt. Okay, that's better. So let's follow the instructions. cd API .NET restore. Restoring the packages, you remember it creates the package JSON log file. Downloads the packages, and .NET run. Boom. So the app, the API will be is hosted in this window, in this command window. So to see that, let's open up Explorer and type HTTP localhost 500,000. So the scaffolded web API has an endpoint that I know by heart, which is API/values, and it yields 2 results. And this proves that it is running on my machine locally. It's interesting to notice that whenever a request arrives to the command line app, it gives us some information about, for instance, how long did it take to serve it. So now let's stop it. Ctrl+C, fire up Visual Studio Code. It's opened already. Let's open the folder from here. Open folder, C shared, oh no, it's not in shared. C ignite API. Select folder. And we can see, are you familiar with ASP.NET? Yes. Web API, good. Values controller /values, right? So /API/values get, it gets the 2 values. So that's the code that we've just ran. Now we want this to run in Docker. So since I wanted to use VirtualBox, I've installed the Docker toolbox on my machine, so I don't have the native Docker for Windows. But it's exactly the same because the Docker command line interface is the same. To Dockerize it, we can use Yeoman from the terminal in Visual Studio Code, for instance. And we just have to type yo docker. Oh, we already have a Docker file, but that's not the one we want to use because this targets the latest production image, and instead we want the development image because we want to remote debug into Docker. So yo docker, and it will take a while to come up. So this Docker container, this Docker generator for Yeoman supports Golang and Node.js apps, but we will select .NET Core, that's what we want. Version RTM. Does your project use a web server? I suppose so, yes. 5,000, we really like 5,000. Let's call it API, yes, API is fine. We'll call our service in the container API, yes, why not? What you want to name your compose project, API is fine. It's overwriting our Docker file, yes, because we don't want the prod image. And what does it do? It adds a bunch of files to our application. The most important one is a PowerShell file. And this is basically, I could go through the details if you want to later. But this PowerShell file is the engine of our Dockerization. And the good thing about it is that Visual Studio Code calls it's layered, right? Visual Studio Code calls the launch.json. The launch.json calls the task.json, which calls into the PowerShell that then calls the Docker file, creates, downloads the image, creates the container, and builds everything. So the good thing is you can customize it, and it's easy. It's a white box. You can just get in and figure out how it works and make it do what you want to do, and it's intuitive. For instance, the Docker file that we are going to use now to Dockerize the app and remote debug it gets the debugger from an SH file, which is at this URL and da-da-da-da-da. So it's pretty easy. Well, it's pretty easy to read, I would say. And it's ready, right? It's out of the box. You can just have to, hit F5, and you see it calls PowerShell, and it executes Docker task.ps1 with a certain parameter, compose for debug, which tells Docker to use the debug application. Oh, yep, this is happening because I'm using the Docker toolbox. So I need to tweak the PowerShell file, and I need to call a batch file that I've created, docker env, that basically refreshes the environment variables. So F5 again. Otherwise, it can't talk to Docker. Building the image, and now it works. So it builds the image, it runs a bunch of steps, downloads the image. Yeah, we can't read them. Too quick. So now it doesn't run on localhost. So if you would be using the Docker for Windows native, you would be able to debug it pointing to localhost. But since I'm using Docker Toolbox, I need to find the right IP address of the Docker machine. So to do that, I need to type Docker machine IP default, which is that one, and point to that, 0.99.100 /API/values, and here we go. So we are remote. Oh, we're not remote debugging it yet. It's running in the Docker machine, and we are remote debugging. Yeah. So I can just put a breakpoint here and refresh, and boom, we hit the breakpoint. So we are remote debugging a .NET Core application in Docker. So, to recap, if there's only one thing you should take away from this presentation, if you want to write a .NET applications or services that are portable and efficient, use .NET Core. I've added a bunch of references at the end about .NET Core, DevTools, the links to the demos that I've just run. Oh yeah, take the picture. But I think they will publish the slides, so don't worry. And information about the .NET Standard Library, recommendations if you want to port your apps to .NET Core or ASP.NET Core, and yeah, how to set up Docker on your machine. So I'm going to leave this here, why not? And yeah, don't forget to evaluate. You could win very cool prizes offered by Microsoft. So I will leave this cloudy slide here. And what's the time? Do we have time for questions? Yes, I think we have 10 minutes, about 5 minutes. So yep, if you have any questions, I'll try to answer as clearer as I can. Otherwise, you can just have a little more time to reach the next presentation. Thank you. I'll be around here anyway.